Alright folks, today we're going to be learning about the volume of pyramids. So you will need a calculator and your cheat sheet out. Make sure you have those so you're ready to work with this video on practice here. Alright, so at the top of your screen here you should see three separate formulas for the volume of pyramids. Okay, the first one is our basic formula, and we're going to use that all the way through today. Okay, but then the second two, they're broken down into the types of pyramids we've been working with. We've got rectangular pyramids, that just means the base is a rectangle, and then we've got square pyramids, the base is a square. Okay, you'll notice the 1/3 shows up in front. 1/3 is going to show up for any volume problem of a shape that has a point on it. Okay, so pyramids will have 1/3, but also when we get to cones, they'll have a 1/3 in front. The rest you should be familiar with, the area of the base times the height, from our work with prisms. Okay, so over here, length times width gave us the area of our base. Over here, side squared gives us the area of the base when our base of our pyramid is a square. Okay, so a couple different breakdowns, but the big idea, we're going to do 1/3 area of the base times the height today. Since we need the height and we're not always given it, this first two problems are just practicing solving for x if we've got some stuff missing. Okay, reminder to you that when we're solving for x, we have to work with this triangle here. The 8's going straight up and down. This 12 is the entire length, and that makes this bottom length on the triangle 6, half of that entire base length. Okay, using that, we can say 6 squared plus 8 squared equals x squared, like we're familiar with doing. Okay, we've got 36 plus 64 equals x squared. Add those together to get 100. And then square root in that last step to get our length of x going this direction here. Now, because our x is going this direction and slanted, remember, we call that the slant height. And that's not involved in our formulas here while we're working with volume. Remember, that shows up when we're talking about surface area. This slanted side is on the surface of the shape versus the height going through the middle there. Alright, what I want you to do is pause the video and then do number 2. Go ahead and solve for x. This one over here is giving the actual height of the pyramid, which will give us our h value in all of these formulas. Okay. Hopefully you remembered this bottom distance is 8, making our height there 15 inches. Make sure you're getting labels on those pieces. So now we're going to put it all together to give the volume. What I want you to start out by doing is just writing the formula for volume. It's got a point, so it's 1/3 area of the base times the height. We need big B and H here, so we'll lay out those two variables so we can set up our problem. Alright, big B deals with the base or the bottom of our pyramid here. You'll notice the shape of it. We've got 16 and 16. That makes it a square. The area of a square is side squared. That looks like 16 squared in this case. Okay, that's a bigger number than we're used to working with, so if you need to type that in, go ahead and do it. We should get 256. The height then is always going straight up and down in our pyramid, and you'll notice it's missing here. Okay, so we need to throw down an x so we can solve for that missing piece. Across the bottom, it's half of the total distance, 16. So we've got 8 going on the bottom, then our x squared, and 10 squared. Now, hopefully you're getting familiar with these Pythagorean triples, so we don't have to do this every single time. Okay, we did just use these same numbers in a little bit different sense up above, but we get x squared here equals 36, and x is 6. So that for us goes in our triangle right here, but also gives us our height of our pyramid, which is going to be used in our formula. Alright, so now what we're going to do is take these numbers and plug them in right here. Okay, 1/3 stays. Big B comes next, and that was our 256. And then our height is last. Now, I'll always put parentheses to talk about these multiplication, but when you're typing in your calculator, you don't need to do that. You can just say 1/3 times 256 times 76 to make your process a little faster. Alright, so we've got 512. Hopefully you remember from last time, volume is, we have 3 different dimensions, length, width, and height. So we've got meters cubed in this case. Alright, we'll do another example here together. We're supposed to find the volume of this shape. Okay, again, it's got a point, so we're using 1/3 area of the base times the height. We need big B and H. Alright, so take a minute to look at the base and decide, is this base a rectangle or is this base a square? Alright, you'll notice our dimensions here are the same, so we can say the area is going to be side squared for a square, and that looks like 24 squared. Okay, bigger number than we're used to seeing, so 24 squared, 576 is the area of our base right here. Alright, we also need the height going up and down. Once again, we don't have that, so we need an x. So I want you to pause the video and go solve for x for me. With our x being 5, we can say that our height of this pyramid is 5. So plugging everything in, we've got 1/3. Area of the base was 576, and then the height was 5. So over here, 1/3 times 576 times 5. Volume for this pyramid is 960, labels feet, so feet cubed. I want you to pause the video, and I think you can handle 5 completely on your own. Okay, set up the variables that you need, and then plug them back in. Make sure your label is correct based on volume. Alright, again, our base here is a square, so side squared is 100 in this case. Our height was already given for us, so that was nice, just the 6. You only want to solve for a missing piece if you're going to need it for our formula. We did not need it in this case. Putting it all together, we get 200 meters cubed. Now on the next one, we still have a pyramid, so our formula doesn't change, but when we're looking at big B, the area of the base, you'll notice we have 2 different dimensions here. So this is a rectangular pyramid. Okay, the area of a rectangle instead of side squared is just length times width. So we're taking the length 12 times the width 8. (96). Height of this pyramid, again, was given to us, so we don't have to work hard to solve for anything here. And then we put it all together in our formula. Okay, so plugging it in, we've got 1/3 times the area of the base times the height, 3. Now, I want you to go ahead and type this one in, and then I'm going to talk for just a little bit about what is special here. You can do this actually on a lot of different problems here. When you look at this one in particular, you see 1/3 and 3. Well, the 1/3 and 3 cancel each other out. So 1 divided by 3 times 3, they equal 1. So if you ever see that, you can cross that out, leaving only 96 to be our volume here. Feet cubed. Alright, last 2 problems involve both surface area and volume, so we've talked about volume enough, now let's put it together with surface area. Okay, I'll show you how to set up this first one so you can stay organized when you do this on your homework, and then I'll let you do number 8 by yourself. Okay, so surface area, this is why I had you grab out your yellow sheet. We're bringing it back from before. Okay, surface area is always the lateral area plus some number of bases, and in this case we've got 1 base, so it's just LA plus B. Okay, but LA is 1/2 perimeter of the base times the slant height. Okay, so we have a couple different things involved for this one. We've got the perimeter of the base, we've got the slant height, and then we need big B still for the area of the base total. Alright, so looking at our base, since it is a square, the perimeter we can find just 12 plus 12 plus 12 plus 12, that's really 12 times 4. Slant height is the slanted side. You'll notice it's missing in this. Okay, so we need to find that. we've got 6, we've got 8. From the couple examples up above, number 1 and number 3, hopefully you're noticing this pattern, 6, 8, 10 triangle. So our x is 10 in this case, which means our slant height is 10. Okay, since this is your practice, make yourself a note, either write down the work or just say, we got this from 1 above. Okay? Then, let's go look at the base here, big B. Our base in this case is a square, so we can say side squared or 12 squared, 144. Putting it all together here, lateral area was 1/2, the perimeter was 48, times the slant height, which was 10. Type that in for me. You'll get 240. Then we'll go and plug that 240 up above here, plus 1 base, so plus 144. Okay, so 240 plus 144, we get 384. And then meters squared. Now, once we work hard for that, we don't have to work very hard for volume, because volume is 1/3 times the area of the base times the height, and we already have these pieces laid out for us for the most part. Okay, so 1/3 times B, we already found, was 144. Now what you'll notice is H was missing. Okay, over here we had the slant height, not the height of the pyramid. Okay, so going back to our picture here, the height of the pyramid was H. Okay, so make yourself a note of that. H here is equal to 8. And then we'll go ahead and plug it in. So 1/3 times 144 times 8. And we get 384 meters cubed. Alright, so you'll notice in this case something weird kind of happened. We got the same surface area as we did the volume, and sometimes that happens. Okay, I want you at this point to pause the video and try doing both the surface area and the volume for the next one. Okay, set it up like we did on number 7 here. Find all the variables you need and then substitute them in for the formulas. Alright, so setting this up, the perimeter here, since it's a square, we can say 16 times 4, 64. Slant height was given to us as 17. The base 16 squared is 256. Plugging it in, the lateral area is 544. We add the 1 base 256 to get 800 inches squared. On volume, you may have noticed that we are missing the height again. Okay, so we had to go use Pythagorean theorem to solve for the height, and then plugging in 1/3 times 256 times 15, we get 1,280 inches cubed. Now, what I would like to point out here is when we're asked to find surface area or volume, okay, it didn't matter what we were given to start out with. We had to use Pythagorean theorem to solve for x no matter what. So if you have to find both, it may be a good idea to go find that missing piece first. That way you have everything ready when you go to actually plug stuff into your formulas. Okay? Go ahead and flip it over to the back, and we've got a word problem dealing with this surface area volume idea. Okay, so we are told this shape here, this compound shape, is a metal storage bin, and it's going to be used to store wheat this winter. We want to know how many cubic feet of wheat will it hold. Now, cubic is going to scream to us volume, but also anytime it's talking about hold, that means inside, and that's going to indicate this is a volume problem. All right? Now, before, when we were dealing with compound problems, we had to worry about the number of bases that were involved. Okay, where these two were touching, we didn't include those bases. We had the lateral area of the first one, lateral area of the second one, and then we added in 1 base at the very end of the problem because only the thing on the bottom is something on the outside that we could touch. Well, with volume, we don't have to worry about the bases because whether or not the bases are included doesn't affect how much it holds on the inside. Okay, so that makes volume a little bit easier. All we have to worry about is volume 1 and volume 2. So the first thing I'm going to do is set up volume of the pyramid. And if you want, you can just say this is 1, and you can say V1 equals. Alright, the reason I like to write the shape here, or draw this shape, is so I know I'm using the right formula. Okay, this is what we were talking about today. This has the 1/3 involved because there's a point on it. So 1/3 area of the base times the height. Okay, my second one that I'm going to be dealing with is a rectangular prism or a box. Okay, and that's just the area of the base times the height. Okay, you'll notice that the same kind of letters are showing up in both of these. Okay, and we have to talk about whether they're the same values or different values for these. Okay, so looking at my first one only, we're just focusing on this top shape. Okay, what I want to know is the area of the base for this shape going to be the same as the area of the base for this one. Okay, and hopefully you'll see that they have to be the same because the bottom of the box and the top of the box are the same. Okay, and that top of the box here in the picture is our base of our pyramid. Okay, so these bases have to match up. They're exactly the same. Okay, so when we're dealing with this bottom being a rectangle, we have to do length times width. So that looks like 10 times 6, which equals 60. Alright, so we can immediately over here say, well, we know that this area of the base is 60 as well. That didn't change. Okay, but our H is a little bit different. Okay, H, as we go through just looking at the pyramid, the height going up in here is 3 feet, so we can plop a 3 down. The height on the box over here is 5. Okay, so make yourself a note, your H is different. Okay, they don't have to match up because how tall they are, one doesn't depend on the other. They can absolutely be the same, but most commonly they are different values. Okay, so they're not the same H. But now that we have our values, we can go plug it all in. Okay, so we've got our first one being 1/3 times 60 times 3. Again, what I told you about that 1/3 and those 3s, those just cancel out. So my volume 1 is 60. Okay? Down here, if we plug stuff in, we've got big B is 60 times 5. So our second volume is 300. And then all we have to do to find the total volume is just add these two together. So 60 plus 300 is 360. The label on both of these are cubic feet. So feet cubed. And that's our answer. Alright. On part B it says, if 1 bushel is about 1.24 feet cubed, how many bushels of wheat will the bin hold? Now there's a rule for kind of getting this quicker, but when we're dealing with things we're not as familiar with, it's always best to just set up a proportion, because we don't know whether we're supposed to multiply by this 1.24 or divide by this 1.24. Okay, so we do know that 1 bushel is 1.24 feet cubed. Now it's important to keep these labels on there because that tells you what to put on the other side. Okay, it says how many bushels. So that's our X. Well, bushels we put on top, so we're going to say X bushels on top. And then on the bottom, that's where our feet cubed goes. So we have to take our feet cubed from up above, this 360, and plop that on the bottom here of our proportion. Then we can see X gets times by 1.24. And then 1 times 360 is just 360. That tells us we need to divide that over. So we're going to say that how many bushels of wheat will this hold? Okay, well it's going to be about 290.3 bushels. Then the cost of the wheat, it says recently rose sharply from $8 to $8.50 per bushel. Okay, so cost per always means we got to multiply. It says per bushel we have 290.3 bushels, and they're $8.50 a piece, so we have to multiply. Okay, cost we're going to always multiply, and then that's by 850. Now you have this number in your calculator, so you're welcome to just take this times 850, but you'll notice that's just a little bit different of a price than if you use the 290.3 times 850. Okay? This is if we don't round our answer, this is if we do, and it's just different by a few cents here. So most commonly we're using the rounded version, so I'd say this is going to cost $2,467.55. Okay, so there's a word problem that deals with volume. Right? You have a homework assignment. If you have any questions on some problems, especially those word problems, please come in to see me.